Transformations of exponential functions and logs. So just like usual, here's our transformations graphic. So let's run through this one more time. So we have a in the front. That's this box here. If you have a greater than 1, it's a vertical stretch by a. If you have a less than 1, it's a vertical compression by a. And then if a is negative, it's a reflection over the x-axis. So a's will multiply the y values on your tables. Then we have b on the inside. That's this box here. This is the one that's backwards. All the inside stuff is backwards. So if you have a b greater than 1, it's actually a compression, and it's a compression by 1 over b. So for example, if you have a b value of 2, that means your compression factor is actually 1 over 2. If you have a b value of 1/3, that means your stretch factor is actually 3. It flips over. So b greater than 1 is a compression horizontally. B less than 1 is a stretch horizontally by 1 over b. And then if b is negative, that means a reflection over the y-axis. And b will multiply your x's. Then we have the x minus c on the inside. So if it's x minus c, again this is backwards, it's a shift right by c units. If it's x plus c, it's a shift left by c units. And this one is added or subtracted to your x's. And then last but not least, we have the d value at the end. So this is the one that makes sense. If you have plus d, it's a shift up by d. Minus d is a shift down by d. Let me fix that, hold on. By d. And this one is either added or subtracted to your y's. So example 1. Describe the transformations from the function f of x equals 3 to the x to g of x equals 2 parentheses 3 to the negative x minus 1 power plus 5. So first, let's try to describe. But I also need to make sure that I don't have a b value that needs to be factored out. So I look in the front of my x's right here, and I see that it does have a coefficient in the front. So I need to factor out this negative 1. So the function I'm actually going to be using is 2 times 3. If I factor out negative 1 from here, because that's what the b value is, my new exponent is really negative 1 parenthesis x plus 1. Always factor out your b. And then we have plus 5 at the back. So describing transformations first. So the 2 in the front, that is our a. So since the 2 is greater than 1, that means there was a vertical stretch by 2. That's one thing that happened. Then I do have a b value of a negative 1. So it wasn't horizontally stretched or compressed, but it did get reflected over the y-axis. Then I have a c value of a plus 1. Remember, use the one that had b factored out. C value of plus 1, which means we had a shift right. Oops, sorry, not right. Shift left 1. And then I have a end value of plus 5, which means it was shifted up 5. So there's the description of the transformation. Now let's go on to the graph. So the first table here is for your parent function. So the parent function is y equals 3 to the x. So this is a growth. So that means I can have positive and negative x values. So I'm going to start with an x value of, let's say, negative 2. So if I substitute negative 2 in for x, 3 to the negative 2 power is 0.111, repeating. Then I'm going to substitute negative 1. So 3 to the negative first power is 0.333, repeating. Then I'm going to plug in a 0. 3 to the 0 equals a 1. I'm going to substitute a 1. 3 to the first power is equal to 3. I'm going to substitute a 2. 3 to the second power is 9. Now if I substituted a 3, 3 to the third power is 27. Well, that's going to be way off my grid already. So we're just going to leave it as -2, -1, 0, 1, and 2. The second table is for your multiply. So that's the A and the B. So the A is what multiplies Y. The B is what multiplies X. So if I look at my equation, I do have a B value of -1. Remember, the B's are always flipped. So if it says that B is -1, what you're multiplying by is really -1 over 1, but flipped around. But if you flip a -1, it's still a -1. Then your A, I do have an A of 2. That's the one that stays the same. So all my Y's are going to be multiplied by 2. So let's perform this operation. So on the X's, -2 times -1 makes a +2. -1 times -1 makes +1. 0 times -1 makes 0. 1 times -1 makes -1. And 2 times -1 makes -2. Now for the Y's. 0.111 times 2 is going to be 0.222. 0.333 times 2 is 0.6666. I'll do a fourth one. 1 times 2 makes 2. 3 times 2 makes 6. 9 times 2 makes 18. And for my final table, to get my last transformation, this is the add subtract table. So your C value is what affects X, and the D value is what affects Y. So for C, I see that it says +1, but again, I need to go backwards. So instead of adding 1, I'm really subtracting 1. And for D, it's +5, and this is the one that you actually do what it says, Y +5. So let's perform these on our table. 2 minus 1 makes 1. 1 minus 1 makes 0. 0 minus 1 makes -1. -1 minus 1 makes -2. -2 minus 1 makes -3. Now for my Y's. 0.222 plus 5 is 5.222. This will be 5.6. I'm just going to round. 2 plus 5 makes 7. 6 plus 5 makes 11. And 18 plus 5 makes 23. So this is my final transformation table. So this blue one is the end result of all my transformations. So I'm going to graph both. I'm going to graph my parent function first. So the parent function is -2, 0.1, so somewhere around there. -1, 0.333. Then we have 0, 1, 1, 3, 2, 9. So remember that exponential functions have an asymptote here on the x-axis, so it's not going to dip down below the x-axis. So we're going to start low, connect all my points, and raise up. So that's the original. Now let's graph our new one. So we're going to graph 1, 5.2-ish. Then we're going to graph 0, 5.6-ish. Then we're going to graph -1, 7, -2, 11, -3, 23. I can't actually plot. Now, this one's kind of odd because we don't really know where our asymptote is, but we do. The shifts up, down, left, and right also move the asymptote. So let's think. If I take this line and I was supposed to shift left 1, if I shift this horizontal line left 1, it doesn't really move. But I also have to go up 5. Well, if I shift this horizontal line up 5, 1, 2, 3, 4, 5, my new horizontal asymptote is actually here. So the shifts up, down, left, and right also move the asymptotes with your new functions. Oh, that's why it's off. I can't count. Here we go. So that point that I fixed should have been -1, 7. I had it at -1, 6. So there's the new graph. My blue one is my new one. My red one is my parent. The last thing it wants is domain and range. So domain and range of the blue one. So domain is furthest left to furthest right. Well, this still goes left all the way, and this still goes right all the way. So my domain is still all real numbers. Now for the range, the lowest it's going to go is this asymptote here. So now it's at 1, 2, 3, 4, 5. but remember, you'll never touch an asymptote, so we need a parenthesis. And then the highest it goes is infinity. So there's my new range. Example 4. Describe the transformations from the function f of x equals log base 2 of x to g of x equals negative log base 2 of 1/2 x minus 2 plus 1. Then graph the function and describe the domain and range. So we have to make sure we don't have a b in our new function, but we do. We have a b of 1/2. So I'm going to have to divide out that 1/2. So the function you're actually dealing with is negative log base 2 of, divide out the 1/2. That's what comes to the side. So I get x. Now negative 2 divided by 1/2 is negative 4. Then plus 1. So always make sure you're dividing out your b before you start describing transformations. So we have describing transformations. I have a negative in the front. That's my a value. So since it's negative, that means that there was a reflection over the x-axis. Then I have a b value of 1/2. So that means it was horizontally stretched because it's backwards from a. Now it's not horizontally stretched by 1/2, it's horizontally stretched by 2. Always flip it over. Flip over your b value every time. Then we have an x minus 4 on the inside, so that means there was a shift right 4. And then we have plus 1 on the outside, which means it was also shifted up 1. So now let's start our graph. So the first one is the parent. So now the parent is y equals log base 2 of x. So trying to find the parent function values for logs can be a little confusing. So remember how to make this into an exponential function. So this is 2 to the y will equal x. So I'm going to make my first x value a 1. The domain for logs is all the numbers greater than 0. Because if we remember, logarithms have a vertical asymptote here on the y-axis, which means I'm not allowed to use an x value of 0. So the next one I can do is a 1. So here's what the question really is asking. 2 to what power will equal a 1? Well, the only way to make anything a 1 and an exponent is having that exponent be 0. So 2 to the 0 will equal a 1. So now the next number I'm going to try is a 2. So again, here's the question. 2 to what power will equal 2? Well, the only way to get 2 back, so 2 to what power? Well, that's going to be a first. So 2 to the first will give me a 1. So here's the problem I'm actually doing. 2 to the what power equals x. So if I tried 2 to the y was a 1, well, that meant y had to be a 0. Then I tried 2 to the what will give me 2, well, that meant y had to be a 1. So if we're doing powers of 2 here, it doesn't make sense to use the next x value as a 3 because no exponent will give me 3 as a value on the output. So the next power of 2 that I have available is a 4. So 2 to the what power will give me a 4? Well, that answer is a 2. 2 squared gives me 4. Now again, 5 is not logical because no power of 2 will give me a 5. The next logical one would be 8. 2 to the what power gives me 8? Well, that would be 2 to the third. 2 times 2 times 2. Then we can try one more. The next power would be a 16. 2 to the fourth power, 2 to the what gives me 16? Well, that would be a power of 4. So with logs, it's kind of backwards. The y values are your exponents, and the x values are the results. 2 to the 0 power equals a 1. 2 to the first is 2. 2 to squared is 4. 2 to the third is 8. 2 to the fourth is 16. Logs are kind of backwards from exponential functions. So change your log into an exponential and work from there. Now let's talk about our transformations. Parent function is the hardest part for this one. So the first table is the multiply table. So that's my a and my b. Y is the a, x is your b. So first, let's see if I have an a, which I do. My a value is this negative, so that means my y's are going to be multiplied by -1. Then my b is a half, but remember we have to flip over b every time we use it. So instead of half, my b's are going to be multiplied by 2. So let's go ahead and get these numbers. 2 times 1 is 2, 2 times 2 is 4, 4 times 2 makes 8, 8 times 2 makes 16, 16 times 2 makes 32. Now for the y's, we get 0, and then 1 times negative 1 makes negative 1, 2 times negative 1 is negative 2, negative 3, and negative 4. The final table is the add subtract. So D is the y and C is the x. So I have a C of negative 4, but remember again, instead of minus 4, this is backwards 2, so we're really adding 4. And then D is plus 1, so we're really adding 1. That's the one that makes sense. Now let's go complete these numbers. So 4 plus 2 makes 6, 4 plus 4 makes 8, 8 plus 4 makes 12, 16 plus 4 makes 20, 32 plus 4 makes 36. I'm going to add 1 to all of my y's. 0 plus 1 makes 1, negative 1 plus 1 makes 0, negative 2 plus 1 makes negative 1, negative 3 plus 1 makes negative 2, negative 4 plus 1 makes negative 3. Okay, now we have both. Let's go graph them. So my parent function I will graph first. That's in the red, so I have 1 comma 0. So now we need to be careful because 1, 0 is actually here in the middle because these go by 2's. So 1 comma 0, 2 comma 1, 4 comma 2, and 8 comma 3. So again, it's going to hug this asymptote and so it's kind of the exponential function rotated. Now let's graph our new one, our transformed function. So we're going to have 6 comma 1, 6, 1. Then we're going to have 8, 0, 12, negative 1, 20, negative 4. Okay, so let's see what this looks like a little bit. So we need to find our new asymptote. So remember, the shifts is what control the asymptotes. So here was the original asymptote, and then I had a shift up 1, which if I move this guy up 1, it's not going to change. But I also had a shift right 4. So my new asymptote is 4 over. So 1, 2, 3, and 4. Okay, so it's going to get very close. So the part that's getting closer is this left side. So my graph really is going to look something like this in the end, which makes sense because it was reflected over the x-axis. So it should be the backwards direction from the original. Now let's talk about domain and range. So the domain of my new function is, well, furthest left I'm allowed to go is this asymptote right here at 4. So I need parentheses 4. But then the furthest right I can go is forever, so that's going to be infinity. My range for this one, well, the lowest it goes is forever, so that's negative infinity, and the highest it goes is also forever, so that's positive infinity. Writing equations for transformed functions. So for example 5, let g be a reflection over the y-axis followed by a vertical stretch by a factor of 6 and a translation 4 units left and 2 units up from the graph of f of x equals 2/3 x. Write a rule for g. So all a rule is an equation. That's all that is. So first of all, we are starting here. That's the original. So now let's see what happened to it. We have to go in the correct order. So the first thing it says, well, there's a reflection over the y-axis. So that's the first thing we need to do. So a reflection over the y-axis means your a is a negative 1. So a is multiplied to the entire function, like this. So negative 1 on the outside of the entire function. So if I distribute that in, well, I can't really multiply it because 2/3 has that exponent of an x. So we're just going to have to leave the negative on the front of the parentheses. Then it says followed by a vertical stretch by a factor of 6. So vertical stretch by a factor of 6 is really an a value of 6. So now, second thing that happened is I'm going to have an a value of 6. So 6 gets multiplied to everything that I already had from the previous step. So if you multiply 6 in, you end up with negative 6 on the outside of 2/3 to the x. Then it says a translation 4 units left. That's the third thing that happened. So 4 units left means that's my c value. So that's going to be up here inside the exponent. So y equals negative 6 times 2/3. And then if I go left, that really means I'm adding 4. And then the final thing that happens is it says 2 units up. Well, I can just kind of tag that on the end here. This is that step 4. So the final transformation equation is this guy. Example 6. Let the graph of G be translated 4 units right and 1 unit down, followed by a vertical compression by a factor of 1/3 and a horizontal stretch of 2 from the graph of f of x equals e to the x. Write a rule for G. So we are starting with e to the x. And the first thing that happens is a translation 4 units right and 1 unit down. Translation you can do at the same time. So we're going to have y equals e. So 4 units right means I'm going to subtract 4 inside the exponent. 1 unit down means I'm going to minus 1 on the outside. Right is the c, down is the d. Then it says I need a vertical compression by a factor of 1/3. So that's the second thing. So that means my a value is 1/3. Now that gets multiplied to everything that's already there. So we're going to have to distribute in the third. So 1/3 times e x to the x minus 4 is just 1/3 e to the x minus 4. Then 1/3 times negative 1 makes negative 1/3. Then it says that there was a horizontal stretch from 2. Now this is where it gets kind of weird because horizontal is your b value. And if it says 2, that means your b is really a half. You always need to flip over the number. So where the half is multiplied is actually up inside the exponent. So it's actually 1/2 times x minus 4 inside that exponent. So 1/2 times x is 1/2 x, and then 1/2 times negative 4 is minus 2, and then minus 1/3 on the outside. So all of this is actually inside the exponent. And there's the final transformed function. If f of x equals log base 2 of x, and g has been reflected over the x-axis with a horizontal compression of 1/3, followed by a translation 9 units right and 4 units up, what is the equation for g of x? So again, we're starting with this log base 2 of x. So the first thing that g, it has been reflected over the x-axis. So if it's the x-axis, that means your a value is a negative 1. So your first thing is putting a negative 1 times the entire function. But negative 1 times a log is just negative log base 2 of x. Okay, then the next thing it says was a horizontal compression of 1/3. So horizontally compressed is your b value, and we need to flip it. So b is actually a 3. So since it's horizontal, it goes inside here with x. So y equals negative log base 2 of 3x. And there's nothing to distribute or simplify. Then it says, followed by a translation 9 units right and 4 units up. Translations you can do all at the same time. So we are going to have the 9 units right. So negative log base 2 of 3x. And then if I'm going to the right, I'm going to do minus 9. And 4 units up is plus 4 on the outside. This is the final equation for g of x. Given that f of x equals the natural log of x, and that g of x has been translated 3 units right and 1 unit up, followed by a vertical stretch by a factor of 8, and a reflection across the y-axis from f of x, what is the equation for g? So we're starting at natural log of x, and the first thing that happened to it was translated 3 units right and 1 unit up. So 3 units right is the c, so that's going to go inside the log, so x minus 3. 1 unit up is the d value, so it goes on the outside. Then we're followed by a vertical stretch by a factor of 8. That's your a. And again, a is multiplied to the entire function. Everything that's there gets multiplied by 8. So 8 times a natural log is just 8 natural log of x minus 3. Then 8 times 1 makes 8. Then it has a reflection across the y-axis. So reflecting across the y-axis means your b is negative 1. Just like a, b gets distributed to everything inside. So negative 1 parenthesis x minus 3 on the inside. Distribute out this negative 1. So we have 8 natural log of negative x plus 3. And there's the final equation for my transformed function.